In this video, we're going to take a look at synthesis, decomposition, and combustion reactions. We're going to review what they look like, so how to identify them, and also how to predict products of some simple synthesis and decomposition reactions, as well as combustion. So we'll start off with synthesis reactions. That's when you have two or more compounds or elements that come together to form one new substance. So you have two or more things coming together to make one thing. Synthesis means to put together, to build. So if you had many parts of a table, so the legs and the tabletop and screws, you have a lot of parts. When you put them all together, it makes one table. Many things make one. Synthesis. There's different cases for synthesis reactions. And so if you just identify the patterns and the trends, you'll be able to predict what the products are if I give you the reactants, and we'll do some examples of that. But the general equation for a synthesis reaction is A plus B, react to produce, so put an arrow there, AB. So many things make one. So the first cases you'll see, or general types of synthesis you'll see, is when you have a metal reacting with O2, oxygen gas, to produce a metal oxide. And all that means is a metal oxide is simply a compound of metal and oxygen. So an example of that is magnesium, some solid magnesium, reacting with some O2 gas. And when they react, they produce some magnesium oxide, which is an example of a metal oxide. And there will be a video linked to see a demo of this. So you can click on that link there to watch this reaction actually happen. And you can describe the observations that you've seen. But here's a cool thing. Now that you know this case, this scenario, metal and oxygen give you a metal oxide, you can easily predict the products for a variety of different reactions like that. Just the only thing that's different is you'll have a different metal. So how do you find the formula? You just need the crisscross between the metal and oxygen. So for example, over here, when I had magnesium and oxygen, to find MgO, I simply did Mg, 2 plus, because it's in the periodic table, O2 minus, crisscross it, I get MgO, Mg2O2, and you divide by 2. To reduce, and you get MgO. So if you think you're ready to try the next two on your own, you can do that. If you still need to watch as a guide, please continue watching. Otherwise, just pause the video, try it on your own, and then check your work. So here we have sodium plus oxygen reacting and want to predict the product that will be made. You need to recognize you have a metal and oxygen, so that's going to be a synthesis that makes a metal oxide. To find out what the formula is for that compound, you simply do Na plus 1 in the periodic table, O, 2 minus or minus 2, crisscross them, and you get Na2O. So you get Na2O. And for the most part, the substance that's produced is going to be solid. The metal will be a solid, the oxygen will be a gas, and then the substance produced will be a solid. Now, keep in mind, this isn't balanced. If you wanted to, you could go and balance it. I'm not going to balance all the equations in this video. I'm just going to show you how to predict the product. But at the end, balancing is the same as you normally would do. So you need 2 oxygens. So that makes 2 oxygens in total. But now you need 4 sodiums, because 2 times 2 is 4. So just put a 4 in the front here. You have 4, 1, and 2. And there's your balance equation. You can try the next one on your own. You have calcium plus oxygen. And they will produce a compound between calcium and oxygen. So you have to do the crisscross again. And you can do Ca plus 2, O minus 2, crisscross it, Ca2O2, reduce, and you get CaO. And don't forget, that'll be a solid. And so that's a very simple one to predict. You just take your metal, take your oxygen, crisscross them to find the subscripts. At the end, if you're told to, you can balance as well. So in this case here, to balance, I need 2 here, 1 there, and now it's balanced. So that's just one of the cases for synthesis. There's a few other cases that are possible. Another one you might sometimes see is when you have a non-metal reacting with oxygen. And when you have a non-metal reacting with oxygen, that'll produce a non-metal oxide. It's basically just a compound that has oxygen and some other non-metal. Now, it technically doesn't make sense to do crisscrossing with non-metals because they don't really exist as ions, right? The crisscross is really for ionic compounds because they have ions, and you're trying to balance the charges of ions, but there's no ions here for molecular compounds because they share instead. So when you get a situation like this, if you have to predict, you can do a crisscross and it will work out for the most part, but it's not really the best practice. You can draw Lewis structures and you can figure out how many will be bonded to each other. Or you could just put a reasonable compound that you have some knowledge of for now. So for example, if I had H2 and O2 reacting, a reasonable compound would be H2O. Notice we have two nonmetals. We have a nonmetal over here plus the oxygen gives you a nonmetal oxide. So a nonmetal element with oxygen combined there. C plus O2. There's two possible answers that I would accept here. So you can pause the video and try to figure out what they are. One answer I would accept is CO2, carbon dioxide, don't forget it's a gas, or CO, gas. For the most part, I'll make you predict mostly metals and oxygen, and also metals and nonmetals, which we'll do in the next case here. So our case C is a metal and nonmetal other than oxygen. It's very similar to what we've already seen, except we're just not dealing with oxygen. So if a metal reacts with a nonmetal, it'll make a binary ionic compound, which is just an ionic compound made up of two different elements. A good example is sodium reacting with chlorine. When they react, they produce sodium chloride. You can see a binary ionic compound has been formed. How was this determined? By crisscross again. You had sodium plus 1, chlorine negative 1, crisscross it, and you get NaCl. And just like before, for the most part, the compound produced will be solid. So if you feel like you're ready to try the next one on your own, you can. So pause the video, try it out, see if you can get the correct product. And then if you, then when you're ready, you can unpause and take a look if you're on the right track. So K plus I2. So I know that's a metal and a nonmetal. And that means that I have to do a crisscross. So K plus 1, I minus 1. Crisscross it, you get K1, I1. And you don't have to write the 1. So Ki, and then it's going to be a solid. If you're asked, you can balance. You can put a 2 here, and a 1 there, and now it's balanced. So these problems here are great because they force you to review some naming, writing formulas, writing chemical equations out, and also balancing. So it's a great practice problem to do because, again, you're kind of studying most of the unit within a few problems. All right, the aluminum and the sulfur. So a metal and a nonmetal reacting. Aluminum we know is 3 plus, sulfur is 2 minus. Crisscross it, you get Al2S3. So Al2S3 solid. And you can, of course, try to balance this. So I think the best approach here is to put an 8 here, to put 16 here, and to put a 3 here. So that would be 16 aluminums, 24 sulfurs, and 24 sulfurs. And there we have our product predicted. So if in a question I ask you to simply predict the product, you just have to predict. But if I say predict and balance, first predict by doing the crisscross, and then at the end, balance. Another case that you might see is that of the nonmetal reacting with a nonmetal, similar to the nonmetal reacting with oxygen, except you won't get a nonmetal oxide, you'll get a binary covalent compound, which basically means two or more nonmetals connected to each other to make a molecular compound. Again, crisscross doesn't really make that much sense here, so I won't ask you to predict these too often. You can do a crisscross, like I said, that will work for the most part, but it's not always appropriate because you don't really have ions and charges in molecular compounds. They share rather than transfer. So for now, if you can just recognize or propose something reasonable, if you get something like this, that's all I really expect. Really, for the most part, you're going to be doing cases like case A and case C. But just to show you what it looks like, here we have P4 plus Cl minus gives you PCl3. O2 plus Cl2. You could do a crisscross, so you can get O2 Cl1 crisscross, and you get OCl2. And this actually does work out. That is an appropriate compound to put down. But keep in mind the crisscross, is kind of like a cheap rule that doesn't always work with molecular compounds. It really does work more for ionic. The best thing to do for something like this is to draw out Lewis structures, but we're not going to focus too much on that right now. And so this here would be in the form of a gas as well. You wouldn't need to know that. I would give you more information about that. So for the remaining cases of synthesis, you'll see that they're highlighted in green. What that means is that I wouldn't expect you to predict types like this, but I would expect you to know how to recognize that there's still synthesis. So for example, if I gave you this SO3 plus this H2O over here, and it makes one new thing, well, you know that's a synthesis reaction. Okay. If you are interested in learning this, how to predict the products, you can go ahead and try to learn it independently. Otherwise, like I said, for the most part, I just need you to know how to identify that these are synthesis reactions. So for example, here I'd get HNO3 aqueous. And again, the trick is that you have two things coming together to make one, so it's synthesis. Here you'd get H2CO3 aqueous. And the trick once again is two things making one. Okay, so anything green is simply enrichment. I wouldn't expect you to know how to predict it, just to identify that it is synthesis. And what's interesting here is that you had a non-metal oxide reacting with water and it made something called an acid. And so we'll learn about acids in more detail later on. And once we do, this will make a bit more sense to you. You could have a metal oxide reacting with water and it makes something called a base. So a base is essentially something that contains this hydroxide polyatomic ion, and we'll learn more about bases later on. But if you take a look, here's our metal oxide reacting with water, and you get calcium hydroxide, which is a base. Here, we have aluminum oxide reacting with water, and you get AlOH3, which is a base with hydroxide. And you might have already seen, the only thing I did to figure out this formula is crisscross between the metal and hydroxide, the polyatomic ion. Here, I have K2O plus H2O. That would give me KOH, which is a base. So again, just recognizing that this plus this, two things making one, is synthesis, is what I need you to know for these enrichment ones. Another enrichment case that you might see is a metal oxide with carbon dioxide makes a metal carbonate. So it just means a metal with the carbonate to polyatomic ion. For example, the zinc oxide and carbon dioxide make zinc carbonate. Here, calcium oxide plus CO2 gives you calcium carbonate. The idea, once again, is that two things make one, therefore synthesis. Copper 2 oxide plus carbon dioxide gives you copper 2 carbonate. Synthesis reaction. Magnesium oxide plus CO2 gives you magnesium carbonate. Synthesis reaction, because two things make one. So in this video, we reviewed what a synthesis reaction was. We saw a few different cases of synthesis reactions. We saw metal with oxygen. To find the product, you simply do metal crisscross with oxygen. We saw a metal with a non-metal other than oxygen. That gives you a binary ionic compound. Just do the crisscross to find your product. And we also saw non-metals reacting together. So non-metal and oxygen gives you a non-metal oxide. Doesn't really make sense to do crisscross. You can do it, but it's not really true there. So anything reasonable like water here, for example, or CO2 or CO here works out just fine. And then we also saw two nonmetals reacting together to give you a molecular compound. Same idea there as the nonmetal and the oxygen. Doesn't make sense to do crisscross. You can, just know it's not really a true thing to do. You need to do Lewis structures. That's why for the most part, we're going to focus on those where crisscross is possible, like the metal and oxygen and metal and nonmetal reacting together. The green ones, once again, were simply enrichment. You don't have to know how to predict those, but you will have to know to identify that this, for example, is synthesis, because two things coming together makes one. If you are interested in learning how to predict them, you can simply watch the videos and look at the general rule highlighted in green, and that will give you an idea as to how to figure it out, and you can compare your answers to the answers in the video. In the next video, we will go over how to predict products of decomposition reactions.